Dear students, welcome to lecture 5 in structural analysis 2, unit 2 arches. So in this we are going to see about a semicircular arch. So the question is, derive an expression for horizontal thrust in a two-hinged semicircular arch carrying a point load at the center. So they have given the problem. Based on this problem we need to draw the diagram. So let us consider it is a semicircular arch. So we know that circular means this distance is nothing but, if it is the center, then this distance will be r, and this point, this will be r, and this will be r. It is nothing but the radius. So here if you see, we have the condition, that is, this is the radius, and we know that to calculate we are going to take a small segment. Here also this will be also can be considered as r. Next what we are going to take a small segment, that is a smaller area at some point. Here let us consider this point. So what we are going to do, we are going to take this so this point. So this is the smaller area. Here we can consider as d. So this value will be also r. So what we are going to do, we are going to calculate this value, because we know that we have already seen in the curved beam, that is this point. If you are applying a load at this point, then the load will get transferred here only, that is at A and B only. But due to the impact, that is load acting here, and we know that we can calculate only the load, that is the reaction in straight line. So only we are drawing this line. So if you calculate this, let us consider this as an angle theta. So this angle is making this portion is making an angle theta. So if you calculate, then this side, this will be, this horizontal is r, this hypotenuse is r, and this is a right angle triangle. So we can apply the trigonometric function. So this is nothing but the opposite side. So opposite side by hypotenuse, we know that it is nothing but the sine theta. So this value, let us consider this as y. Let us consider this as y, and y equal to, we know that r sine theta is the formula. Next what we need to calculate, we need to calculate this portion. Let us consider this as x. So x equal to r cos theta. So this is the value. Next this portion, this is nothing but, we can consider this as x1, because this is the unknown. So x1 will be, we know that this is total length is nothing but r, and we need to minus x. So if you write it, then r minus r cos theta. So the finalized answer will be r into 1 minus cos theta is nothing but our x1. So we have calculated the required answers, that is what is the value of y and what is the value of x1. So next, if you see in book, they will use the notation here x1, and here they will use it as x. So we can consider this as x, and this as x1, and this as x. So I have changed the notation as per the book, because while giving book you will get confused. So I have changed as per the book. So we have calculated the value. Next what we need to do, we need to calculate the point load acting at the center. So here, I have missed the point. Here the load is W. So if you calculate the reaction, that is VA, half of the load, because it is acting at the center, half of the load will come here. So VA will be W by 2, and VB, vertical reaction, will be W by 2. So we have calculated the reaction and the other required answers. So next what we need to do? Next we need to calculate the answers, that is we need to solve the problem. So we know that in order to calculate the horizontal thrust, we will use the strain energy concept, right? So our ultimate goal is, what we need to do, we need to calculate this horizontal thrust H, and because both the side we will have the same value. So we have calculated the required answers. So next what we need to do, we need to calculate the bending moment. Let us consider this section, this x as region x. So let us consider this region, this is not x, This is the x-axis region. So what we need to do, we need to calculate the value. That is, we need to calculate bending moment at x region. So m equal to mu into, we know that m at x, m equal to mu into h into y. Mu is nothing but this VA into x. So equal to VA into x minus h into y. So this is the formula. So we know that what is x and what is y, we know the value. So what we can do, we can directly substitute the answer. So we know that VA is nothing but W by 2 and x is nothing but, if you see here, x is nothing but r into 1 minus cos theta minus h is nothing but h and y is nothing but, we have calculated here r sin theta. So we have calculated the required answer. So next what we need to do, we need to substitute in the formula, strain energy formula. So we know that strain energy due to bending is u equal to integration of mx square divided by 2ei into ds. Here ds means you need to consider a small segment. So if you consider, let us consider a small segment like this. That is, this is the center point, this point. So I am mentioning this point and I am going to take a smaller area here. So I have taken a smaller area and this portion, and this distance is nothing but, we will consider this as ds. So here the angle is d theta, or you can consider as d phi. Here we will consider d theta and this is nothing but r. So this ds value will be equal to, if you calculate this ds is equal to r into d phi, because we know that if you are going to if you are going to calculate the segment value, that is, this is a small segment. So if you are going to calculate this segment value, then it is nothing but radius into angle. So that will give the segment length. So that is r d phi. So we know that u equal to, we can substitute this. We know that from the condition, that is dou u divided by dou h equal to 0. So this is the condition to calculate the horizontal thrust. So what we are going to apply in this condition. So here we know that u is nothing but mx square 2ei. So if you simplify this, what I am going to do is I am going to substitute this in here. So integration of 1 by 2ei, that is 1 divided by 2ei, and the value mx is, here if you see the mx value we have written, it is nothing but mu minus hy the whole square. This is nothing but mx into ds. Instead of ds, so I am going to write r d theta. So I have written this. So next what I need to do, I need to again, this is nothing but u. So I am going to substitute in this condition, that is in strain energy condition. So in order to calculate the value, I am going to substitute it here. So what I am going to do, I need to integrate it. So dou u by dou h. And the limit which we are going to is, we are going to take a smaller region, that is from 0 to pi by 2. So I am going to take this segment because this segment is the mirror image of this. So if I calculate value for one segment, then I can multiply it with 2. So what I am going to do, I am going to take this 1 by 2a is common. So 2 into, because I am taking only the half of the segment. So 2 divided by 2ei integration of 0 to pi by 2. Remember, this total distance is 0 to pi, but I am taking only this 0 to pi by 2, one portion of the arc, so only I am mentioning 2 here. So 2 by 2ei, if you differentiate this, then it will be 2 into mu minus hy. Here we are differentiating with respect to h, so here we will get minus y into r d theta. So here again what I am going to do, I am going to substitute the value, that is I am again, this 2 and this 2 will get cancelled. So I am taking the common term, that is 2 by ei integration of mu value. We have calculated this mu value as VA into x. So that is nothing but WR divided by 2 into 1 minus cos theta. This is nothing but mu value minus H into R sin theta is nothing but our hy value. Next again what we need to do, we need to consider this minus y. So if you see here y value is minus sin theta. So again R minus R sin theta into here again we are having one more R. So here again we are having one more R, that is R d theta. So this portion is commonly taken outside. So what I am going to do again here, if you calculate, then the value will be 2 by E8 sorry, this total portion is this, not here. So this total segment is this value mu minus hy, so I have taken it in the bracket, into minus y, so I have taken it again in the bracket. So if you see here in this bracket we have the r common, here also r common. So integration of 0 to pi by 2, here also 0 to pi by 2. So what I am going to do, I am going to take the r as common. So r into w by 2 into 1 minus cos theta minus h sin theta into minus r sin theta into r d theta. So this is the simplified answer. So again what we need to do, based on this we are going to do the value equal to 2 by E8. Here if you see in all the these three are in multiplication. So I am taking this r common. So r cube integration of 0 to pi by 2 w by 2 1 minus cos theta into sin theta, because I am multiplying this sin theta inside. So 1 minus cos theta into minus sin theta, here also we will have the minus, plus h into sin square theta into total d theta. So this is the total answer. So this total time will come into d theta. So again what we need to do, in order to solve the problem, what we are going to do is we are going to split this term. That is, here if you see I am taking minus common, 2r cube divided by E8 integration of 0 to pi by 2 w by 2 1 minus cos theta into sin theta d theta plus integration of 0 to pi by 2 h sin square theta d theta. So this is the total term. So again what I need to do, now I am going to do the integration. So here if you see this is like an UDV format, that is if you take u as 1 minus cos theta. Remember this is a simple step to solve the problem. So du, if you calculate du, then it will be sin theta into d theta. So if you look here, this is nothing but u du format. Like if you consider this, then these two terms is like an u du. So what I am going to do, I am going to directly take that. Instead of solving this, I am substituting a simple condition, that is I am taking this 1 minus cos theta as u and sin theta d theta. By integrating this, I am getting sin theta d theta. So this term represent du and this term represent u. So minus 2r cube divided by E8 integration of 0 to pi by 2 w by 2 into u du plus, again sorry, here we won't have plus because here we have commonly taking the minus outside, so it will be minus. Here also we will have minus, I am writing downward, 0 to pi by 2. So remember sin square theta is nothing but 1 minus cos 2 theta divided by 2. So I am substituting this formula because we can't integrate the sin square by theta value. So I am going to substitute this 1 minus cos 2 theta divided by 2 into d theta. I am taking h commonly outside. So remember minus 2r cube by E8 into w by 2. If you integrate this, then this value will be u square by 2, 0 to pi by 2. So I have taken this term. So next what I need to do, so I have taken this. Next minus of, what I need to do, I am going to take this h outside. So I am going to substitute here h by 2 as common. So if you integrate this, 0 minus sine 2 theta divided by 2. So what I need to do, 0 to pi by 2 is the limit. So I am going to substitute this. Here remember dou u by dou h, because we are taking dou u by dou h, it is equal to 0. So minus 2r cube divided by ei into w, u square is nothing but pi square divided by 4. Again already we are having 2, so we will get it as, sorry, we have done a small mistake here. So while substituting the, instead of while converting theta to u, we need to consider the limit also. So if theta is equal to 0, then u value will be, if you substitute it here, we know that cos 0 is 0, so u value will be 0. And if you substitute theta as pi by 2, cos value is 0, so u value will be 1. So remember this is the limit condition also. So here when we change the theta to u, here we need to consider the limit as 0 to 1. So here also the value will be 0 to 1. So if you substitute it, then the value will be 1 square divided by 2. W by 2 into 1 square divided by 2. So this is the first segment, minus h by 2. So instead of, if you substitute value here we will have pi by 2 minus, if you substitute here sin pi, so sin pi value is 0, and if you substitute 0, then the value will also be, if you substitute the lower limit 0, so then the total value will be 0. So this is the total segment. So what we need to do, we need to calculate the h by 2 value. Though, so this 2r cube divided by a is common. If I bring it to this side, it will become 0. So I am equating h by 2 into pi by 2 equal to w by 2 into 1 by 2. So if I simplify this value, I will have this 2, this 2 and this 2 and this 2 get cancelled, and the h value will be h equal to w divided by pi. So this is the simplified answer. Remember, when you convert this term into simplify, in order to simplify this term, we are converting as u equal to 1 minus cos theta, and if you differentiate this, then we are getting sin theta into d theta. So when we substitute this, instead of theta, we convert this into u, then you also need to convert the limit. So here if you see, I have done the mistake because I haven't changed this limit, but after calculating I have done this. So if you take theta equal to 0, you need to substitute in this equation. So u equal to 1 minus cos theta, that is cos 0, we know that 1, so 1 minus 1, so the value will be 0. If I substitute cos pi by 2, we know that cos pi by 2 is 0, so 1 minus 0 is 1. So this is the limit. Instead of 0 to pi by 2 limit, we are changing it to 0 to 1. Remember, we are doing this for this particular segment only, not for this, because here we are converting into, again we are simplifying that in terms of trigonometric function only. So we don't need to change in this portion, we need to change only in this portion. So if you have any doubt, feel free to contact me. Thank you.